Thanks for joining us today for the Unit 3.1 Forces and Interactions Unit Overview. My name is Janita Vasquez. I am the Program Manager for Elementary Development at OpenSciEd. And joining me today is Audrey Mohan, who is a Senior Research Scientist of BSES Learning, and she's also the lead for this 3.1 unit. So we're glad to have her here with us today. So let me just give you an idea of what we will go through in this webinar. So we're going to give you a little bit of information about OpenSciEd. I'm sure there's plenty of folks in the call that are familiar with our middle school and high school materials, but I'm still going to tell you a little bit more about elementary. Audrey will take us through part of the unit. She'll help us experience and talk about what happens during lesson 1, our anchor phenomenon. And she will also walk us through the storyline so that you can get a better idea of what happens in this unit from beginning to end. And then she's going to share some key features of the unit, some things that she is really excited about and wants you to note about this grade unit. And then we will maybe answer some questions. Okay, thank you. Now, about OpenSciEd Elementary. So OpenSciEd is a nonprofit organization that brings together amazing curriculum developers like Audrey, state science administrators, teachers, and philanthropic organizations that help us develop free, high-quality science instructional materials and professional learning. So in this work, we work with 9 amazing states and who brought us over 450 teachers to help us field test materials. And that means we're reaching around 10,000 students. So all these folks are giving us feedback and helping us to make the units as wonderful as they can be. So a few facts about OpenSciEd Elementary. So first, we have an instructional model. Our units are built using a storyline instructional model, which means we focus on engaging students and asking questions about phenomena, and then using those student questions to drive learning from the beginning to the end of the unit. The lessons in the unit are connected, and we do that really in service of making sense of the phenomenon, and students get to do investigations and research as they make sense of the phenomena throughout the unit. This is our instructional model, and you can see that this is a journey from beginning to end. We have different types of lessons that students are going through as they, again, investigate and research this phenomenon. All right, so our units are built so that they work in real classrooms. We know that in elementary school, you are teaching everything. You are doing all the things. And for that reason, we are building materials that work with whatever your context happens to be. For 3rd grade, we are going to have 4 units. All of our grades have 4 units per school year. And while we have a recommended sequence, these units are meant to be modular. So they can work with your school system, with your kids, with your schedule. Now, we know that sometimes science is not top of the list for elementary school. But again, because we're building materials for real classrooms, we want you to know that teaching these 4 units, it's only about 10% of your school year. Only 10% of the instructional time in your full school year. So in 3rd grade, there are 4 units again. Each of these units has about 15 lessons, and each of those lessons is about 90 minutes long. Now, we do not expect that you are teaching science for 90 minutes at a time. Our units are built to have manageable chunks so that you can think about where they fit best in your schedule throughout the day and throughout the week. So you may have science class for 3 days a week for 30 minutes or 20 minutes a day until you get through each of the lessons. We're really trying to think about what might work best for you. Now, we're really proud of the math and ELA integration in these units. As far as math, we are focused more than anything else on the practices for math, and we are really focusing on math talk and math modeling during our units. As far as ELA, our students are engaging with multiple types of texts and communicating their thinking in a variety of ways. This means orally, in writing, using gestures, using drawings, using the home language if that's what they need to do in their classroom. And just like our middle school and high school materials, our materials are meant to be hands-on. We are currently working with kit providers to have, hopefully, materials ready for purchase and printed materials ready for purchase in January of 2025. Now, if your district or school chooses not to purchase those kits and printed materials, we do also provide kit lists in our units so that you can make those purchases on your own. All right, so now I'm going to hand things over to Audrey so she can help us get to know this forces and interaction units better.
All right, so let's jump into this third grade unit. It's on forces and interactions. It is designed to be the first unit of the year, but like Janita said, these can be moved around throughout the year. Get it to move. All right, so this is a big bundle of performance expectations in this unit, and there is a lot of text on the slide that you're seeing right now. I'm going to just highlight some key aspects of the performance expectations for this unit for you. So we're working in the physical science space. The first performance expectation is really focused on balanced and unbalanced forces on the motion of an object. That performance expectation works really well with the second performance expectation, and that performance expectation is on looking at predictable patterns of motion on objects. So those two are focused on contact forces. So that's a key feature of this bundle. So I'll let you just take a look at those two. And then the third and fourth performance expectations in the unit are focused on non-contact forces. So we're switching over to primarily magnetic forces. And so where students are going to be looking at what happens when two magnets are near each other and there's some forces happening, and how can we use our knowledge about that to solve a problem. And then finally, third grade has a lot of engineering in their units. 3 out of the 4 third grade units are going to have engineering. So we've combined this unit with some of the engineering performance expectations, where students are going to be defining problems and carrying out fair tests to design a solution to a problem. This is going to be in the context of art for most of the unit. So it's not really a problem, but they're going to identify something that they want to design a solution for, a piece of art that they want to design. All right, so next slide will be on our science and engineering practices for this unit. So we are highly scaffolding, asking questions, and defining problems in this unit. We're also working on developing and using models in this unit. And the really big one for the unit across the entire unit is planning and carrying out investigations. There are other practices in this unit as well, but these are the 3 that you'll see lots of scaffolding and support around. Our cross-cutting concepts for this unit are going to be mainly focused on patterns and cause and effect. Those are going to be key cross-cutting concepts for all of third grade. So you'll see patterns and cause and effect in every third grade unit when you're teaching them. And we'll be scaffolding those throughout the year. But this unit also is going to start building some ideas around systems and system models. And we do that in the context of sculptures. So sculptures are made of lots of different moving parts working together in a system. And so students will learn a little bit about systems and system models as well. Okay, so let's get to the fun part and dig into the anchoring phenomenon for this unit. So we want to launch the unit with sharing our experiences with some interesting art. So there are two pieces of art on the slide, and we'll ask the students, have you ever seen sculptures like these before? Now, we strongly also encourage teachers to put their own pictures on here. If you've ever seen a balance sculpture or a kinetic sculpture somewhere in your community or at an art museum, you could go ahead and add those on here, but these are the two that students are going to engage with in lesson 1. So we have them on this slide. And we just want to elicit their prior experiences. Have they ever seen anything like this before? And we use the word sculpture here. So the very next thing that we want to do in the anchor is support the development of that word sculpture. So lots of us think of sculptures as like big blocks of rock or like the MLK memorial sculpture that's on the slide. But what we mean by sculpture and what we put on the word wall is that it's a three-dimensional art object. So it's three-dimensional and it can be big or small. It can be fancy or silly. It can be still or it can move. And it can be one piece or many pieces. And so in this unit, students are going to be building sculptures, and there are going to be many different pieces that create their three-dimensional art object. So now we've kind of elicited their prior experiences with maybe seeing some of these sculptures and thinking about what a sculpture is. And now we're ready to actually observe some interesting sculptures. So we want to support students in noticing things about those sculptures and having some wonderings about them. So take a moment in your classroom and just kind of remind students, like, noticing is going to be something that you observe, you see, or hear it. And a wondering is a question you have about it. So you'll prepare students that way, and then we'll watch a really interesting sculpture. So this is a sculpture that balances in a puzzling way. And this will be the first video that your students will see in the unit. I'm going to play the video through twice so that you can also notice some interesting things about the sculpture. The artist's name is Walter Wick. You may have seen his work in other school-aged publications. And this is an interesting sculpture he built. So I want you, as you watch this, notice and wonder about the sculpture.
Okay, what I'm going to do is balance a whole bunch of toys on a single Lego block.
Okay, let's watch it one more time through. Just so you can see it. You may notice a few things the second time through, just like your students will.
Okay, what I'm going to do is balance a whole bunch of toys on a single Lego block.
All right, so that was a pretty cool sculpture. Kids really love that sculpture and they're pretty excited about wondering how he was able to get it to balance. They'll notice all kinds of things with that sculpture. Oops. Let's see. So what you'll want to do next is set up an interesting sculptures chart. You can do this digitally or on chart paper, but you'll want to capture those noticings and wonderings from the students after watching the video. And I'll show you an example one in just a minute, but they'll say things like different toys on different sides, or he had so many toys, or that Lego brick was really tiny, or that he had support bars to help him build it. So those are the kinds of noticing students may make. And they may wonder, how did that work? How did it balance on that tiny Lego brick? How did the support bars work? Did he use the same weight of objects? Is a common question. So those are the types of things students may share. And now you're going to introduce one more interesting sculpture. And this one is balanced as well, but it's moving in an interesting way. So the first one was a sculpture that stayed still, and this one is going to move. And so again, we're going to just watch the video twice through. And again, your students will make noticings and wonderings as they watch the video. Okay, just one more time. Let me catch it. We'll go back one more time and play it through. Okay, so again, you'll want to capture all the students' noticings and wonderings on that interesting sculptures chart. So the things they'll notice is different paper shapes, and that there was different shapes in the middle on the stand. One had a circle, one had a triangle. They were wondering how much, they may wonder how much people knew how to blow it to make it spin. So you'll want to capture all those questions on your interesting sculpture chart. And here's an example chart for when we piloted this lesson in a classroom, to just show you the kinds of things that kids noticed and wondered. So they, the first balance sculpture with Walter Wick, they noticed that the weight, noticed a weight on each side, or it's symmetrical, or he used things to keep it steady. They noticed lots of things about the toy and that it was balanced. Things they noticed about the moving one were that it was moving and that people were blowing on it, and that it looked like it could fall over really easily, maybe, that it tilted while it was balancing, and it was very colorful. And they have lots of questions about how he used toys, how the bottom was so tiny, how did they make it move, how will it fall off, how many parts does it have to have? So lots of questions about these sculptures. So, but we don't want to stop there just watching sculptures, right? So the very next thing in the anchoring lesson is that students get into groups and they build sculptures. So you're going to give them things, and I'll show a little bit more, but you'll give them like a pre-built base that they can build, kind of like the Exploratorium one. You'll give them all kinds of blocks and things to build with. You'll see them on the picture there. We use just wood rulers a lot to kind of be a balance bar, and wooden dowels. And we give them like just different paper shapes, just cut out of colorful paper, and clips, little clips that they can clip their paper shapes. And you just give them a basket of all kinds of random fun materials, and you let kids be creative in this first lesson and see if they can build a sculpture that balances, and maybe it balances and moves. And that we really want to capture their ideas about what's causing it to balance or balance and move without falling over. So they'll sketch it. Their sketches of their sculptures are really important at this point. We want them to just do a quick sketch of the sculpture they built. But this building activity kind of generates lots of questions from kids about how to make these things work. So now we want to sort all the sculptures that we've seen. So at this point, you introduce category A sculptures that balance. So they're just balanced sculptures. Category B sculptures are the ones that are balanced and they also move. And then you can have a category where you're not really sure. And this is where you'll tape up the Walter Wick sculpture on category A, and you'll tape up a picture of the Exploratorium sculpture on category B. And then the kids get to add their sculptures, the ones that they drew as well. So those little gray squares on this example chart are the student sketches of their sculptures, and they get to place their sculpture, whether it's just a balanced and not moving sculpture or a balanced and moving sculpture, onto the chart. So we're building out all of our examples of these balanced art things that we're noticing. And from there, though, we want to gather other examples. We want to broaden out beyond just art. Kids see weirdly balanced things every day in the world. And so we want to give them an opportunity to look for something outside the classroom that might be balanced or balanced and moving in an interesting way. And so again, they get to sketch what they see in the real world. And they bring those sketches back in to the classroom, and we take those sketches from our community connection. So maybe they saw a balanced sculpture in a local park. I have a park here that has a balanced and moving sculpture that's has butterflies. So maybe I would sketch the butterflies on this sculpture and bring it back in. And I would want to put my sculpture, my example, into category B. And so we want them to bring all those community examples of balanced and moving objects back in and put it on our examples chart. So again, we're trying to just build out lots of relevant art examples and non-art examples where things are balanced or they're balanced and moving. And this is really going to drive their investigations in the unit. Okay, so now we've got lots of different phenomena out there of these sculptures doing interesting things. How do they work? So in one of the final things they do in lesson 1 is they created an initial explanation to answer the question, how do these sculptures balance and move? So we want to just generate our initial ideas about how they work. And so students can pair up with an elbow partner, and they can talk about it and and they can rotate around and just talk about how do they balance and move? Like, how do these things work? And they just want to generate lots of ideas about how they balance and move so that then we can come back together and share those ideas as a class. And so we have our examples chart, and now we're going to add all of our ideas about how we think this type of balanced sculpture works, this one that's not moving, it's just staying still. And we want to add all of our ideas about how this type of balanced sculpture works. It's balanced and it's moving and it doesn't fall over. So how does that work? So we want to gather as many ideas as we can. We want to put question marks around the ideas that we're not sure about, and like note areas of disagreement or things that we want more information about, because that's going to be a motivating thing for the rest of the unit. And so now, ideally, you would have up next to our examples chart of all these different examples in the world, you would have students' initial ideas about how they work. And so some of the initial ideas might be like putting it on a flat surface, maybe having equal weight on both sides, getting it completely centered, going slowly. So maybe an idea about the process for doing it. And that maybe you have to have wind or air blow on it to get it to move, or that you have to have something push it if it's a moving sculpture. These are all ideas that third graders have about these sculptures. And so now that we have all our ideas and all of our, we've observed these in videos, we've built these sculptures, we've gone out into the community and we've gathered additional examples, we've generated our ideas about how they work. And now we're ready to build our driving question board. And this could be students' first driving question board for third grade. And so, generating questions might need a little bit of help. So we've provided students with just a couple of different sentence frames to help structure their questions into questions that we can investigate in the unit. So, how does blank cause it to balance? Or if we do blank, will it balance? So just to give students a little bit of extra help formulating their questions for the driving question board. Then, as in all the Open SciEd units, this is a moment to bring everyone together in a scientist circle, as we call it in Open SciEd. If you haven't set up your community agreements at this point, you'll definitely want to take some time to use the community agreement resources with the lesson to set up community agreements about how we want to work together as a science community, how we want to talk, share, and pursue our investigations together. But it's also really helpful for when we come into these moments where we need to generate a shared classroom product, like a driving question board. We'll have agreements about listening to one another and building on each other's ideas. So we'll gather in our scientist circle, and we have a example of how you might want to organize your questions, but often like one student will share a question and read it out loud, and they'll put it up on the board. And then you might say, does anyone else have a question like that question? And so several other students might have something similar, and they can go put those questions up close to the first question. So now you kind of created a similar cluster of questions about a certain kind of topic that they might want to pursue. And then you might move on to, okay, let's start a new question. And you keep doing that until all the questions are shared and you have a bunch of different clusters of questions. And it looks something like this. So again, these, the questions on this example driving question board, we have it shown here where category A is the balanced sculpture, the Walter Wick one that doesn't move. And category B is the one that's moving. And we kind of separated those questions and then tried to cluster them into groups. And these are actual third grader questions that we got from a pilot classroom to build this driving question board. And then the final thing now is they've got a lot of ideas about what they want to investigate. We need to capture those ideas. So like things they want to try. Do they want to investigate weight? Do they want to try something the same on both sides? Do they want to test out how much to blow on a sculpture? Do they want to test out different shapes for the balance point on a sculpture? You want to capture all of those ideas on ideas for investigation so that you can circle back to this after you've as you go through the lessons, basically. All right, so that is the anchoring phenomenon for the unit. Now let's step back and look at the entire storyline for the unit. And I'm going to show you, because this unit, every single lesson in this unit, you will be building sculptures. It's a very material intensive unit, and it's super fun and hands-on and can get kind of loud in your classroom. So I want to take a moment when I talk about each lesson and actually show you some of the materials and things that you'll be using so that you kind of can envision what we're trying to build in that lesson. Okay, so the balanced art unit is 14 lessons, and they're approximately 90 minutes a lesson. There are 2 lessons in the unit that are a little bit longer because the building in the lesson takes a little bit longer to build the sculptures. So I just want to make everyone aware that this unit doesn't always follow the 90-minute rule per lesson, just because some of the lessons do take longer to build. And again, we don't expect you to do all 90 minutes in one day. It's actually broken up so that you can pace it out across the course of a week or so, however your science is set up. So lesson 1 was the anchoring phenomenon that we just went through. And they do build in the anchor, and they get that big set of materials that they're building with, and they see these puzzling balance sculptures that move in interesting ways, and they generate lots of questions. How does this work? How can we make this work? Can we do this? Like, they're very into building some sculptures at this point. So most of the students have an idea about the sculptures being symmetrical. They may not say the word symmetry, which is totally fine. We help support them with that word, but they say it's the same on both sides, or it's about the same. So that's where we go first in the storyline. Lesson 2 is how can we build a sculpture that balances? And we start with the most basic sculpture here. And one of the things we're supporting this unit is planning and carrying out investigations. So as you'll see on that handout on the unit, we are working on procedural text. So this is a literacy connection as well. So looking at scientific procedures and kind of following those procedures. So we highly scaffold this first build that students do. And the first build that they do is like a Jenga block. Everyone's probably played Jenga. It's like a Jenga block. And they get a ruler, and they have the instructions to put the ruler kind of in the middle of the block, and they literally get two symmetrical kind of colorful blocks, and they place them at the exact same place on both sides, and they just try to get a basic sculpture to balance. And some kids can go multi-level. They can do one more Jenga block on top and one more ruler, and they can go up 3 or 4 levels. It's really fun to see what they can do. But the idea is that we're trying to support them in a symmetrical sculpture where they're practicing measuring distance from the center, which is a good math connection. So they're counting out from the center, and they want symmetrical objects, equal distances from their balance point, which is the point in the middle, the Jenga block meets the ruler. We also in this lesson introduce a chart called the Successful Sculpture Will chart. And this is where we're going to start building some engineering design ideas. We're not going to call them engineering design ideas, but we're going to think about our design goal and what our sculpture needs to do to be successful. So we're kind of building in criteria. We're not calling it criteria till the end of the unit, but we're just trying to think about, like, what does it have to do to be successful, to balance? And then the final thing I'll mention in lesson 2 is that we have a beautiful book called Symmetry. Because the students notice symmetry and asymmetry on the sculptures, we support them in thinking about why would artists want to make something symmetrical? And then why would they want to make something asymmetrical? And so students get to read about symmetry in our everyday world, where we see symmetry, why people use symmetry in art, and then why people might want to use something, make something asymmetrical. And that's where we go next, because it's kind of like a very simple build to use the exact same objects. And students will remember that Walter Wick it looked kind of symmetrical, but the objects were a little different on either side. So could we start mixing it up a bit and go a little different on either side? And so now we're wanting to make our sculptures more puzzling or playful. That was an idea that was introduced in the lesson 2 symmetry book, that asymmetry makes things puzzling and playful. And so they want to try to make something puzzling and playful. And so lesson 3 is a really big lesson to introduce the idea that as long as you have equal weight on both sides of the sculpture, it will balance. You can do different types of objects. You'll notice on the slide there that they have different types of objects. You can do different types of objects, but they get introduced to equal weight. And so in that lesson, you'll use like a digital kitchen scale, and students will begin weighing objects and trying to get objects of equal weight on both sides. They'll keep the balance point in the middle, and they can get really creative with this. And another important thing for lesson 3 is that we introduce the word force for the first time. And they get introduced to the idea that weight is a force pulling us towards the ground. It's a downward force towards the ground. And so they're working with weight, and they start drawing arrows on their models to represent downward forces. And then the final thing for the Connect in lesson 3 is that they get introduced to the artist profiles that are going to carry them throughout the unit. So they get to meet Walter Wick, and they get to learn a little bit about his art and some of the different balance sculptures that he made. And they'll read about other artists as well throughout the book as they go through the lessons. But at this point, like, students have also noticed that some of the artists in that book don't always keep the balance point in the center. So if the balance point is in the center, they start noticing that some of the art is off-centered. For example, this art up here on lesson 4, George Rickey's art, it's called The Ship. That balance point is not centered, and students have noticed that when they look at some of the pictures in the book. And so now they want to try to make an off-centered sculpture. There's another really good example up there of just a wooden ruler and some rocks and a Jenga block to make an off-centered sculpture. And so again, we're working on planning and carrying out investigations. And so this lesson in particular has a lot of emphasis on following these investigation procedures to test distance and test weight, and then just do something creative as an artist. And so they figure out in lesson 4 that if the balance point is not in the center anymore, then the weight has to change, and the weight is no longer equal on both sides. The shorter side has to have more weight. That's as far as they go with this lesson, because to be able to explain these off-centered sculptures is actually high school science content. So all we want them to do is notice the pattern, that as this balance point changes, they have to adjust the weight. And they'll use that pattern in some future sculptures. All right, so that's through lesson 4. Now, I want to say lessons 1 through 4, we've been talking about balancing these sculptures. We are using that word in everyday language to just stay up and not fall over. The unit is on balanced forces. And so that is a very specific use of the word balance in a different context. And we have not introduced the idea of balanced forces yet. We're only working with one force, and that is the downward force of weight. So now they have been reading that Meet the Artist book, and they've noticed that several of the artists build sculptures that hang from above. They don't sit on a hard surface. And so now we're going to move to try hanging a sculpture from above and using some of our ideas about symmetry and asymmetry to see if we can create one of those sculptures that the artists make. And so you'll see in the picture that the students get a variety of materials to create a hanging sculpture. As a class, you'll do a symmetrical mobile first, and then they get to do a creative asymmetrical mobile that you'll see in the picture there. But they'll get these double-ended alligator hooks. These are the best things we found for 3rd grade fingers to squeeze and be able to connect little popsicle sticks. So they can easily just attach them to the little popsicle sticks, and they can also attach them to washers or different objects very quickly to build their hanging mobiles. And I've actually got a hanging mobile to show you, because if I can gently move it over here off my desk, because this lesson actually is now going to introduce balanced forces. And so at this point, students have only been working with sculptures that sit on a desk, and they are not necessarily noticing that there is a force from the desk pushing up or holding up that sculpture. But when we get to the hanging mobile sculpture, they actually hold their hanging mobile. And this is where we introduce the idea that the weight pulling down on the sculpture is the downward force. All the weight on the sculpture represents all the downward forces pulling on the sculpture. But now we have this other force that's holding the sculpture up. My hand is holding the sculpture up, and we call that an upward force. So the upward force is holding that sculpture. And so now we have different forces acting on an object. And if it wasn't moving, that one was moving because of air. But anyway, if it wasn't moving, if it was staying still, those forces are balanced, right? All the weight pulling down on the sculpture and the weight holding up the sculpture is balanced, and there's no change in motion. And so students, we add that big word to our word wall, that when forces are equal on an object in opposite directions, they're balanced. So that's a big lesson to help them understand that, balance sculptures. Okay, so at this point, we've been able to explain a lot about Walter Wick's sculpture, but we have not explained anything about moving sculptures. And they'll notice that the hanging mobiles naturally kind of spin and move, but also we revisit our anchor at this point and we go back to the exploratorium sculptures. And we want to answer some questions about those sculptures and how they move. So we transition in lesson 6 to then thinking about our category B sculptures, our balanced and moving sculptures. And kids right away, they notice the different points on the wooden dowels that they're using. So I have one here. It's got a different point on it right now, but it's just a square dowel, as you can see in the picture. And they want to test what kinds of motion they can get on a sculpture by using different shapes. And so they noticed in the anchor that some of the sculptures used a round ball and some of the sculptures used a triangle shape. And so we want to test that part of the anchor to see what happens with our motion. And so through a series of investigations in lesson 6, they will figure out that triangle shape typically results in a seesaw motion, and the round circle shape will typically result in a spinning motion, although it can kind of go a seesaw too. And then if they have a square dowel with no shape, it typically falls off. They can't get a predictable motion on it. And so again, now we're working on a different disciplinary core idea around having predictable patterns of motion. And so these different shapes will predict different patterns of motion. And then in lesson 7, we want to think about, they watch these moving sculpture, some additional moving sculptures, and they think about how these sculptures are moving because the wind is blowing on them. And so how much force, how much extra force can they apply to the sculpture and in what direction to get it to move the way they want their sculpture to move. And so as they're working with these different sculptures and they're balancing objects, they practice with applying extra forces to the sculpture to see how much force before to get it to move and to balance without falling over. And we call that an extra force. And then we develop the idea that, oh, well, when there's a change in motion, like when it starts to move, it's unbalanced forces, because now there's an extra force happening on the sculpture that doesn't have a balanced force. So that is a situation where the forces on the object are unbalanced. And so now as you can see, remember from our performance expectation bundle, we've been working with balanced and unbalanced forces and predictable motion. And all of these forces have been contact forces, like something is touching something else and applying the force. So we're going to put our pieces together in this lesson 8, and you have 2 options for a summative assessment. You can either do an art exhibit where the students can build a whole art exhibit of different balanced and moving sculptures, and they can communicate about their sculptures to other classrooms. This is a great opportunity to work with an art teacher in your school too, to have maybe like an art showcase of balanced and kinetic art. And students can get really creative with it, and they can bring in objects from home. They can do like recycled materials, or they can do different leaves. If you're doing it in the fall and all the leaves are falling, they can have a theme with their sculpture and name their sculpture, and they can communicate about how it works. So that's one option to summatively assess students. But we provided a second option because sometimes by this point, students are ready to not build another sculpture. And so they can do a transfer task and transfer the ideas that they have about balanced sculptures to looking at balanced games. And so some of these games students have played, like the balance game that you see on the screen here, or there's also putt-putt golf as an example on that assessment, where they have predictable patterns of motion when you play putt-putt golf and you apply a certain force to the golf ball. So those are 2 different options. We don't expect you to do both assessments in lesson 8. Just choose one that feels good for your students and that you have time for. Okay, So now we're going to transition to lesson 9. Lesson 9 is a re-anchor. Most of the third grade units actually do, in the middle of the unit, have a moment where we look at a new related phenomenon. And so in this unit, we now want to get at sculptures that move, balance, or move without anything touching. And so remember, we've been working on contact forces to this point. Now we're going to do non-contact forces and look at sculptures. And so they watched this new video by an artist named Takis. I'm just going to play it quickly for you. And they'll watch it again twice. And notice that the things from above and the things from below are not touching, but things are moving. I think it gets a little closer here in a second. Oop. So it actually zooms in and gets a little bit closer. And so in this lesson, we're going to transition. At this point, we've really been strongly supporting planning and carrying out investigations with students. Now we're going to switch over and support asking questions and modeling a little bit more so in lesson 9. And so in the re-anchor, students generate their initial ideas about how this sculpture works. Nothing's touching. So how are the things moving on this sculpture? And they're not touching. And they also get some of these other stationary objects where nothing's moving and nothing's touching, but like the earth is hovering there. How does that work? And so they generate an initial model in this lesson, a zoomed in picture of the Taki sculpture, and they will add ideas to their diagrammatic model as they work with magnets. And so here. So in lesson 10, students have ideas that it has something to do with the magnets on the sculpture. They think there's definitely something there with the magnets. They're not really sure. And so in lesson 10, we generate some questions we want to investigate about magnets. And we're doing cause and effect questions about magnets. And then they test it and they figure some ideas out. Some of the ideas they figure out is that like sides of the magnets will push away. So the direction of a force, there is a force. They do figure out that there's a force between magnets, and that the direction of the force pushes away if the like sides are facing each other. And that if it's unlike sides, then they will pull together. So we don't talk about it as like north and south poles, which we often see with magnets. We talk about it as the like sides and unlike sides. And so they get one idea about the direction of the force between magnets, which is really helpful because they're going to need that idea when they apply it at the end of this lesson set. So they know that they're not touching and that there is a force and that there is a direction. And then in lesson 11, they start experimenting with how strong they can get that force and how far apart the magnets have to be. So Taki's sculpture had the bigger magnets floating and moving from above, and smaller magnets moving around. And so they're testing ideas about like, well, can a bigger magnet create a stronger force between magnets, or how far apart do the magnets on the sculpture need to be? Let's test the distances. And so they run 2 more tests with magnets, and they figure out that stronger magnets have stronger forces between them. And if the magnets are closer together, it's also a stronger force. Smaller magnets or weaker magnets have a weaker force, and the further they get away from each other, the force gets weaker. And so that gives them some ideas about the placement of the magnets to create a certain amount of force between the magnets. And then the final thing to test this Taki sculpture is to think about other materials used on the sculpture. So what happens if we, like with magnets, interacting with other materials? And so students will test a bunch of other possible materials to use on sculptures, and they will figure out that not all metals have a force, like magnets don't actually have a pull force on all other metals, only certain types of metals, but not all of them. And that then they can apply some other ideas about the distance between the magnet and the other object, and the strength of that magnet to try to hover a paper clip at like the picture that you're having, that you see on the screen here. So they're trying to apply some of their ideas about what metals or what magnets are attracted to and have a pulling force on, and then strength and direct distance to see if they can't create this hovering paper clip. And this is all to give them ideas for the next lesson, lesson 13, where they build a magnetic sculpture. But I also want to mention lesson 12 offers up an electrical force opportunity too, to see if it's only magnets that have a non-contact force between each other. So magnets can apply a force without touching anything. And students actually get to experiment with static electricity. And so they can rub a balloon on wool or their head or some other material and create a bunch of static, and they can actually roll an empty aluminum can around on their desk without ever touching the can. We created some videos for this in case you can't recreate it in your classroom, but it's just to help students understand that there are other ways to have non-contact forces. They will explore those forces more, electric forces more, in 8th grade. So we don't go deeply into electric forces in 3rd grade, but we do want students to understand that magnets are not the only way to create a non-contact force. Okay, so then we're going to wrap up this unit with doing an additional art gallery where they get to use magnets to design new art based on all the ideas they figured out. They can go back to those moving sculptures. In this picture on the lower right-hand side, they can go back to the moving sculptures and create motion with magnets now. They can tape magnets onto their paper objects, and they can actually use their ideas about magnets to make it move rather than blowing on it or touching it. So that's pretty cool. They can also create a diorama kind of thing here with this floating paper clip. So they could put a bunch of different stars in here if they wanted to and have them all float around, and they can actually move them back and forth. Or they can create a stationary magnetic sculpture as well using a bunch of different objects. So those are just some ideas for creating a magnetic sculpture. And this is an assessment moment as well to see what they figured out about magnets. And then the final lesson in the unit is using magnets to solve a problem. So this is one of the performance expectations. And students get introduced to a context of adaptive clothing, where the fashion designers are using magnets in interesting ways to create enclosures instead of using buttons, or magnetic zippers instead of just traditional metal zippers. And so students get introduced to this context where designers have solved a problem in helping people get dressed using magnets. And so as a class, we work through that problem to kind of generate, like, how does it work? At this point, I forgot to mention, but they're working with criteria and constraints. We've introduced them to those words at this point. And so now they work through that as a class using adaptive clothing and think through the criteria and constraints for a successful solution to the problem. And then they get to go into a big brainstorm about how could we use magnets to solve other problems, any other problem that they can identify. And they go through a prototyping process. So they don't actually build new designs with magnets. They don't build solutions to problems, but rather they puzzle through the idea of, like, what could I design? How would it work? How would I know it's successful? How does it meet my criteria? What might make it hard or challenging? Like, what are the constraints? And they kind of work through this design process, just generating ideas for how magnets can solve a problem. And that is the final assessment in the unit. So I know that that was a lot of information on this unit. Hopefully,
Audrey,
not too
can I
much.
ask you some questions before we move on to the key features of the unit?
Yes, definitely. Let's do
Okay,
it.
so a couple of things. I'm just thinking logistics for a minute. So you mentioned at the beginning that students will be building at the beginning every day, every time they do a lesson. In every lesson, they'll be building. So what do I need to know as a teacher in terms of how much space I need? Do I need to leave things up overnight? Do I need a large space? Can you say more about that?
Yes, so we have the building components into 30-minute chunks. And for that reason, so that you do not have to keep sculptures up overnight. So if you can make sure that when they do build that you have 30 minutes, that is the time in which we have recommended baskets of materials, so just little plastic baskets. You can put the required materials into those baskets, and students get 30 minutes to build and record their observations of their sculptures. And then we ask that they pack all their materials back up in the basket and kind of stack them back up for you. So there shouldn't be any overnight work except on the art gallery. Lesson 8, when they're making their art exhibit, those sculptures would probably want to take a little bit more time with it. And so students may want to be able to set those off to the side, maybe even work on them at home too, if they get really sophisticated with it. So that would be one logistics problem. And then the other thing I will say about building, because they are building every lesson, some teachers have said it gets really noisy. These wooden blocks, when they fall on desks and you've got 30 kids in your classroom and wooden blocks are falling over, it can get really loud. However, they do need a firm surface to build on, because building on carpet is also frustrating for kids because it's harder to get it to balance. So some suggestions there are to build on rugs, like a little area rug if you've got like carpet rug, or just build on the floor if you don't have carpet. That's great. It's going to make less noise than a bunch of blocks falling off of desk and stuff. So that is another logistics issue that we recommend. Building on the floor. And then, you can also get like cardboard boxes, and they're flat. So if you do have carpet, you can get cardboard boxes and make them into flat surfaces, and it does give them a firm surface to build on, and kind of muffles the falling blocks as well. But that's a little bit more work to get that set up.
Sure. A different question, and thank you for that answer. That was really helpful. So what if I don't purchase a kit that comes with all these materials? Is it, from what I can see, it looks like I may be able to use whatever I have on hand, as long as at least for the category A sculptures, I have some of the same items that students
Yes.
can balance. Does that matter? Can we change those materials?
You can completely change these materials. We bought to build most of our sculptures, we bought one set of colorful wood blocks. You might already have this kind of thing in your classroom, just little building blocks, or there might be a teacher in your hallway or someone, like you can also, if you're in a campus, you might be able to go down to kinder classroom or pre-K and even borrow some blocks for a little while. So these building blocks they can be used over and over again in many ways, and they're pretty common, but you can also use any other objects, as long as they will balance on a ruler. One of the other things I'll say is that the rulers are, the best rulers to use are wood rulers. Lots of kids will come to school with plastic rulers, and they will bend a little bit. They're not as rigid as the wood rulers. And so when they start putting objects on either side, it will bend if it's plastic. So wood rulers are a really important thing. Paper shapes, just colorful paper. You can get that anywhere. I would say all the wood dowels and stuff, these are easily sourced at a craft shop or online on a online warehouse carrier. You can get wood blocks, you can get wood bases, and this is just wood glue holding it together. So again, this is actually pretty easily sourced and very affordable. And same with these wood dowels. These are, every craft store will have them, maybe even like Target, but definitely Amazon kind of places will have those. The one thing I will say, that the clips, this is a special item. These are sewing clips. We use these sewing clips because they are very easy for little kids to clip things on. to the wood dowels, and they don't really pinch fingers. However, you can use binder clips. So, you know, just basic little black binder clips. Those are fine too. And you can use clothespins, but you would need a way to attach. Clothespins could work for some of the sculptures, but then some of the sculptures, we have these special alligator clips that are double-ended alligator clips. These are not the electrical double-ended alligator clips. So if you ever type in alligator clips, you might see electrical cords. Those are not the ones you would want. You want these are decorative ones, and they're just held with a little wire. They make building so much faster on the hanging mobiles because students can just clip really quickly on both ends and hang things. You can create your own, like you could use clothespins and attach string between the clothespins. You can glue string to hold them together. So there's different ways you could create clips that are double-ended, but it would take some gluing or tying on your part. Popsicle sticks are another thing we use in the unit. And then one of the things that very affordable and can be used across a lot of the lessons are just plain washers. So we recommend getting a variety of sizes of washers so that they can balance the weight. So wood blocks and washers and things like that are easy. The washers are easily clipped. If they need to add weight to one side, they can always take a washer and just add a little bit of weight. So they come in very handy. And the only other object I forgot to mention is when we teach the concept of weight in lesson 3, we teach it kind of conceptually first, like filling it, what feels heavier, and sometimes it's hard to tell. And then we use those little mini plastic springs. They're little party favors, and I have different washers on here. So you can get these at Walmart or Target or anywhere. They're in the little dollar aisle or like the birthday favor aisle. They're just little plastic mini springs, and they are a great way to help students understand that weight is a pulling force toward the ground. So you're trying to define weight as a pulling force towards the ground. And it's a great way for students to conceptually figure out that it's pulling it down, it's a pulling force before you start using the scale to measure weight. So that's just another object that's kind of important for and you only need 2 of them because you're just going to do it as a demonstration for them. But that's another important object that you can get just about anywhere.
Great.
Oh, and then, sorry, magnets.
Yes.
In the second half of the unit, you just need a set of ring magnets, ceramic ring magnets, and you can get those anywhere. They're very easy to source. And just a safety note, when kids are working with magnets, they can pinch their fingers very easily. So we have lots of safety call outs in the second set of the unit to just remind people of fingers getting pinched between magnets and also keeping magnets away from electronics. So that's an important note for working with magnets.
Great. Thank you, Audrey. All right, so let's talk about the key features of the unit. What are you really excited about sharing with us?
Okay, so the first one is obviously the arts integration. So I've worked on a lot of Open SciEd units over the years, and I love this unit's arts integration because once you start seeing balance and kinetic art in this unit, you will start seeing it everywhere in your world. There are lots of artists who work in this area and create really fun, balanced or moving sculptures. And so I love the fact that students can integrate their science with being super creative about art. And they can get really creative in this unit. So they learn about real artists that you do this stuff. They learn about symmetry in our world and asymmetry in our world. So it's just a fantastic arts integration. I am also really excited about the ELA integration. We have 4 texts in this book. We have a text that helps them around planning and carrying out investigations. That's a really strong text there. We have the Meet the Artist book that has these profiles of artists and how they build their art. We have a book for supporting magnets, and we have the book on symmetry. But then we also have all these procedural text that students work through, which is an important literacy integration at 3rd grade. So students working with scientific procedures and kind of working through that. And then we also we have a lot of support around helping students write and formulate like their own questions and their own ideas throughout the unit. So that's another important like writing integration. And then of course we introduce engineering in this unit. 3rd grade is such a big engineering year. So this first integration of engineering is from an artistic perspective around designing sculptures to meet certain criteria and constraints. And it's not until the last lesson that they are then trying to solve a problem that they see in the world using magnets. But it starts getting them thinking about what's the goal of our design? What problem are we trying to solve? What does it have to do to be successful? And what are we limited by? So there's some big kind of engineering ideas. We start working on that in this unit, and they get 2 more units in 3rd grade that carry that forward. And then the final one is this planning and carrying out investigations. We highly scaffold this practice throughout the entire unit so that they get kind of somewhat planned out investigations that they're carrying out and recording notes and thinking about that. But towards the end of the unit, they're doing a lot of the planning and carrying out and figuring out what procedures they need to do and why they need to do them. And so they also, in that text that scientists use procedures, they get introduced to real scientists and they get to look at their notebooks and think about how those scientists recorded their procedures and their results and observations in different ways, both in data tables, but also in sketches and drawings and notes, so that it gives kids an idea that of all the different ways they can record their data as they carry out an investigation. So that's also an exciting part of the unit.
Great. Can you go to the next slide, Audrey? All right, so I have one more question for you. And this is the first time that we heard in the point 1 units about re-anchoring the unit. So I know we have some folks that are new to storylining, and we've been talking about storylining as we have an anchor lesson to set the learning off, and we do some investigations and research to be able to answer our main question. Why would you insert a re-anchoring halfway through or partway through this lesson, this unit?
Well, that's a good question. We tried to get magnetic sculptures in the initial anchor, and it was just a lot of information for students to be tracking around balanced sculptures, balanced and moving sculptures, and sculptures that are balanced in a weird way, but nothing's touching. It was kind of an overwhelming amount of different types of sculptures that they were kind of wondering about in that anchor. And so we decided to just focus on the ones that had contact forces in the first half of the unit. And then because we were transitioning into non-contact forces in the second half of the unit, that we would then introduce them to a new type of sculpture where nothing's touching and kind of create a little bit of puzzling around that to then motivate the second half of the unit. So it was really about the content space. It was almost too much content to try to get into a single lesson 1. And so we divided it that way: contact forces in the first half and non-contact in the second half.
Thank you, Audrey. That makes a lot of sense. We definitely don't want to overwhelm students, and this makes sense in this storyline. Thanks so much. All right, can you move us to the next slide? So I just want to remind everyone, first, thank Audrey for being here today and helping us go through this unit. It is definitely one of my favorite point 1 units. I love the art integration, and the Meet the Artist book I think is one of my favorite in every single unit we've written. So upcoming events, please look on our website for any upcoming events. We are done with our series for our point 1 units in elementary, but we are planning other webinars. And again, in the spring, when we launch our point 2 units, we will have these types of webinars again. So last slide, please. So thank you all for joining us today, and thank you, Audrey. This is a great unit. We hope you will try it. Bye-bye.